Hey everybody, so in this video we're going to be taking a look at an example of using some algebra to solve some complex numbers question. In this case, we're given z being a complex number where z squared is equal to 7 plus 31j, where j is the square root of -1, and we need to find all z that can satisfy this equation, right? And this in real numbers would be quite easy, right? Square root both sides and we're done. But unfortunately, with complex numbers, we can't just take the square root of both sides. We have to actually do a little bit more algebra. So to start off this question, we're going to remind ourselves in the rectangular form, we have a plus b j. That is the complex number where a and b are some scalar values, right? So what we're going to do is actually just make use of this way of expressing it in terms of its real values, a and b times j, and we're just going to sub that into the equation and see where that gets us, right? So let's do that. We've got a plus bj squared, and that must be equal to 7 plus 31j, right? So luckily, this we should be able to solve, right? Because we can equate our real parts and our imaginary parts, and that should give us two equations. We have two unknowns, a and b, so things are looking up for us. So let's expand this, right? This is just a squared plus 2ab times j plus b squared times j squared. This must be equal to 7 plus 31j. And notice that j squared is also just the -1, right? Because square root of -1 times the square root of -1, our square roots will cancel out and it's just -1. Okay? So that'll be a squared. That plus becomes a minus, so minus b squared. This is our real term. Put some brackets around it for clarity. Plus 2ab times j. Okay? And the 2ab is just the scalar quantity of our imaginary component. And this equals 7 plus 31j. So, as we were saying earlier, we have two unknowns, a and b, which we'd like to solve for. So we need two equations, okay? So we can equate our real parts. The real part of the left-hand side is a squared minus b squared. And that must be equal to the real side of the right-hand side, which is just 7. So this is equation number 1. Secondly, we've got the imaginary side equals the imaginary side of the opposing side, right? So that would be 2ab must be equal to 31, right? Not too bad so far, okay? And remember, we don't need to tack on the j's there. We're just equating the imaginary components, right? Perfect, okay? So we got two equations, and doesn't look super duper helpful, so it's gonna get a little bit hairier, but that's okay. So why don't we start with equation number 2, because both of the terms are of the degree 1, and if we were to try to isolate for a variable in equation number 1, it would probably be a lot uglier because we'd have to do the square root of something, and then it just doesn't look as nice. Versus if we were to isolate for an equation or a variable in equation 2, it should be a little bit easier. So let's isolate for a in this case. Doesn't matter which one. Math is math. You could choose whichever. So this is 31 over 2 times b. Okay? And we'll use the same kind of methods that we have always used in algebra. For a system of two equations, let's substitute this into equation 1. So this will be 31 over 2b, this is squared, minus b squared, this is equal to 7. Okay, great. So let's try to simplify this as best we can. Let's just write this as 31 squared over 4 times b squared. Okay, because I don't know what 31 squared is. So we'll just leave that as 31 squared for now. Minus b squared equals 7. All right. We also don't like that b squared in the denominator, so let's multiply everything by b squared. This will give us 31 squared over 4, so some number, and the b squared will cancel out there. This will be minus b to the 4 equals 7 times b squared, right? All we did was multiply everything, the left and the right side, by b squared, right? So now we've got a b to the 4 term, a b squared term, and then some scalar term, which is still kind of ugly. Something like this doesn't look like we can solve right away, but we can do some more algebra to get some kind of readable solution. And the way that we're going to do that is by a quick little substitution of using b. Well, instead of b to the 4, let's make the substitution. Let capital B, let's let that equal to b squared. This way, we should be able to get this equation that we have in terms of a quadratic, right? And we can solve a quadratic. We know how to do that. So let's do that. Okay, substituting this in, we will get, this first term is still a scalar, minus, well, b to the 4, if b squared is just capital B, then b squared squared is b to the 4, so capital B squared is b to the 4. So that's capital B squared equals 7 times capital B. And now we've got a quadratic, so let's do, this is a 0 equals capital B squared plus 7 times capital B minus 31 squared over 4. Okay, it's looking all right. And we can use the quadratic equation here, and it's kind of ugly, and I think that if you're watching this video, you probably can apply the quadratic equation. So I'm going to just pause and get that solution. Okay, so we are back with the solution to the quadratic equation, and you'll notice here, right, we've got, of course, two sets of answers here because it's a quadratic. And this really means that, remember, because capital B is just b squared, little b squared. So this would be minus 7 over 2 plus or minus the square root of 1010, right? And what I want to point out here is, right, because we're still looking for b, and if we were to take the square root of two different solutions here, then I want you to think about whether they would be real or complex, and if that's okay. So once you've thought about that, let's take a look at what's going to happen here, okay? So one set of the solution will be b is equal to the square root of negative 7 over 2 plus whatever square root of 10,010 is, right? Apologies for how ugly this is. And we know that, okay, the square root of 1,000 something will be much bigger than 3.5 or negative 3.5. So that will result in a positive number underneath here, right? This would be positive. And also, I forgot one thing in this as well. Recall that b could be plus or minus the square root, right? Okay. And then we've also got a solution where b could be plus or minus the square root of negative 7 over 2 minus 10,010, right? Okay. So in this case, we've got a negative number subtracting an even larger negative number, which is negative. And what do we get when we take the square root of a negative number? We get a complex number, right? That would mean that b is going to be a complex number in this case. Okay? Let's just remind ourselves what exactly is b, right? Look at equation 1 right here. Specifically where it comes from. A squared minus b squared. Okay? So we can't have our b squared term being a complex number, right? Wait a minute. Sorry for that. So what I mean to get at here is that this a squared minus b squared term will be complex because if b, just the single b right there, if that is a complex number, then a will be a complex number, right? So 31 divided by 2 times divided by a complex number, that'll be complex, meaning that our a squared minus b squared term will also be a complex number, right? And that is not allowed, right? That's a restriction on the equations, right? So we need to consider all the solutions, but we need to also check that they will also make sense. So in summary, lowercase b cannot be complex because it'll make a complex and then our real component will not be real. Okay? Hope that made sense. So let's get back to solving this, right? So we have got b can be equal to, we've got positive square root of whatever this number is, right? Negative 7 over 2 plus square root of 1010. Okay, and then we also have the case where b is equal to minus that, minus 7 over 2 plus square root of 10,010. Okay, great. Sounds good. Okay, perfect. And now let's check with our system of equations. So we know that a is equal to 31 over 2b. So a would be equal to 31 over 2 times square root of negative 7 over 2 plus 10,010. And a would be equal to 31 over 2 times the, or well, negative 2 times the square root of negative 7 over 2 plus 10,010. Beautiful. Okay. Hey. So we've got these two equations right here, or these two sets of solutions. Number 1, and let's call this number 1, and this is solutions 2. So this should be the end of our problem. So z would be equal to, and I'm not going to write all this out, but remember, z equals a plus b times j, right? So sub both of these in, and in this case the numbers are just so ugly it doesn't work out, but hopefully if you're on an assignment or something like that, these numbers should resolve nicely. But you just sub these in and all good to go. And that's how you do a question like this.